Hi everyone and welcome to our next lesson. Today we are talking about parabolas. Now a parabola is the set of all numbers, set of all points equidistant from a point called a focus and a line called a directrix. Okay, and we see some examples of our parabolas. We often see them opening up or down, and then we see them opening left or right. So when we are talking about our vertical parabolas, so again, think about these parabolas that are either opening up or they are opening down. Okay, they are going to involve our x value being squared. So we have y minus k equals 1 over 4 times d, x minus h quantity squared. And the h and the k are your vertex at the bottom here, either the opening up, we would have the vertex here, opening down, we would have our vertex there, and it's our h comma k. Now those are all going to be folded over an axis of symmetry. So think about in this case that for a vertical, it's going to be a vertical line that we could, sketch through here that we could fold these over. Those are your axis of symmetry. And in this case, they are a vertical line. So they would be x equals, in this case, the value that they are going to fold over. Now, inside of our parabolas, there is what we call a focus, okay? And so basically what we do is we have our h comma k value, and in these parabolas, your focus is kind of a point inside which that this is opening towards, right? That's our focus. So for a vertical one, we are going to be changing the k value. It's either going to be above or below, depending on how it's opening. D units, which we'll talk about a little bit later, that would be our focus. It's a point inside, again, we're opening towards. The directrix is almost the opposite of that. Okay, if we have our up and down, the directrix is the one that we're going away from, and this is going to be a line as well. Okay, so our focus was a point, vertex was a point. A directrix is going to be a line. And in this case, it's the line kind of going that these parabolas will point away from. So in this case, they are going to be horizontal lines that we would be moving away from. Now, to determine is this opening up or down, basically we want a positive 1 over 4d value to make it open up. We would have a negative 1 over 4d value out front to make it open down. Now, the directrix and the focus are both going to be the same amount of units away from that vertex. So we call that parameter d, and it's, again, the same distance from that vertex value, whether you were going from the focus to the vertex or the directrix to the vertex, and that's going to be parameter d. Now, again, a lot of these things are going to hold true then if we are talking about a horizontal one. So if we open to the right or to the left, essentially are horizontals. This time what happens is our x value is the unsquared value. The y value is squared. So y minus k, quantity squared. And again, the vertex is your h comma k. It's going to be that point either the left here or the right. Those would be your vertex. This time our axis of symmetry, we'd be folding over a horizontal line. So in this case, it would end up being, again, think about like you're folding over this horizontal line to make it fold on top of itself. So it's y equals, and then whatever you're folding over. Our focus is still a point, but this time when we are opening, our point is coming to the right of the vertex or the left, depending on how it's opening. So we would be adding or subtracting left or right, so we would actually be changing the h value, the y value of it, the k does not change at all. When we open our parabolas again to the left or the right, this time our directrix is going to end up being a vertical line. So that's going to be an x equals line that we move away from. And then a positive 1 over 4d value makes these open to the right. A negative 1 over 4d value has us opening to the left. And then again, that distance from our vertex to the focus or our vertex to the directrix, just because it's opening left to right, it's still d units away. So we have a couple examples here then of actually kind of using that fact to find our different values. So we have a vertex on this one at 1, -3. So we have our h value with x, k value with y. This time we have an x that is squared and a positive value out front. So we know that this is going to end up opening up. Now our d value is actually going to be the next thing we want to calculate. We know that 1/2 equals 1/4 times d. If we cross multiply to solve, 1 times 4d is 4d, 2 times 1 is 2. Our d value this time would be 2 divided by 4, aka 1/2 or 0.5. So that means if we are opening upwards, our focus is going to come half a unit above, and this is going to open up. Our directrix is going to come below half a unit. So our focus again is half a unit above 1, -3. So that's going to be at 1, -2.5. Directrix is a horizontal line this time, and again it's going to be half a unit below our value that was at -3, so it would be going through -3.5. Last but not least, our axis of symmetry this time, if you kind of thought about, okay, where can I fold this over so that our parabola is on top of itself? Well, it's a vertical line this time through 1. All right, if we look at our next example, we see that our y value is squared this time. So in this case, with the y value being squared, we know it's either opening left or right. In this case, to the left, because it is a negative value out front. Our vertex, our h, k, h is always with x, k is always with y. We are at 8, -3 this time for our vertex value. And our 1/4d is going to be equal to 1/12. So we cross multiply and solve this time. We get 4d times 1 equals 1 times 12. D this time is 3 units. So because this is opening to the left, we know 1, 2, 3 to the left would be our focus. 1, 2, 3 to the right, so a little off the graph, would be our directrix. And we always open towards that focus value. So our focus value again is to the left 3 units, so that is going to put us, our focus at 5, -3. Directrix this time is a vertical line 3 units to the right of 8, -3, so that would be through 11, a little off the graph. Last but not least, our axis of symmetry, if we fold over this time, it's going to fold over the y value, it's a horizontal line this time, of 3. In this case, -3, right? And you can always kind of check these always stay the same for your axis of symmetry. All right, last example together. This time we have an x squared, but our x squared is got a negative out front. So in this case, we know we are going to have, negative, a downward facing, since it's up or down for x squared, negative means we are going to go down. And our vertex this time, our h is always with x, our k is always with y, -5, -6 would be our vertex value, so that's down here. Now notice this time we just have a negative out front. That's just basically telling us that -1 would be that value on the outside, or again just 1 if we're kind of thinking about 1/4d. So in this case, if we cross multiply and solve, think about it's 4d or -4d equals 1. D then would be -1/4 or 0.25. So the negative, again, is just helping us figure out that this is opening down. The real thing that we need here is that 0.25, because we are going to have a focus point 0.25 below our vertex. So that's going to be at -5, but down another quarter, so -6.25. And then our directrix this time would be a horizontal line 2.5 units above -6. So that's actually going to come through -5.75. Our axis of symmetry this time, we are going to fold over through a vertical line, so an x equals, and in this case, -5 would be that x value we're folding over. All right, the last one is for you to try. And thanks everyone for watching. We will definitely work more with these in class.